Assalamualaikum and greetings everyone. We are still on scalar field, but today we're going to look at the second item, which is directional derivative of a scalar field. Okay, now let's look at the definition. Okay, so if you're given a scalar field z equals f of xy, we have learned in chapter 2, we know how to determine partial derivative. So partial f partial x is the derivative in the x direction. Partial f partial y is the derivative in the y direction. So now we want to find the derivative at any given direction. Okay, not just in the direction of x or in the direction of y, but we want it to be in at any given direction. Okay, let's say you have z equals fxy is a scalar field, and u is a unit vector. It's very important here. U here must be in unit vector at point P. So we have point P, x0, y0 in the domain of f on the xy plane. Then the directional derivative of f at point P in the direction of the unit vector u is denoted by duf, and it is defined as the gradient of f or del f dot u. So gradient of f or del f here is a vector, dot with a unit vector u. So when you dot two vectors, what you get is a scalar. So directional derivative of f in the direction of u is a scalar. Okay, now let's look at an example. So here we are asked to find the directional derivative of z in the direction of vector a at point P. Okay, so we have z is equal to f of xy, which is 3x squared y, and the direction a here is given as 3i plus 4j, and you can see that a here is not a unit vector. In order for us to be able to use this formula, the direction must be in unit vector. So here we're given the direction, which is vector a, but it is not a unit vector. So what we need to do is we need to find a unit vector which is in the same direction of a. So what we do is we take a, divide by its magnitude. That will give you a vector which is in the same direction as a, but the magnitude is 1. So this would be 3i plus 4j divided by the magnitude, which is 3 squared plus 4 squared. So that will give us 25. Square root of 25 is 5. So we have 3 over 5 I plus 4 over 5j. So this unit vector u is in the same direction as a, but the magnitude is 1. So now we can use the formula, but in order for us to be able to use the formula, we need to find the gradient of f. Okay, so the gradient of f is a vector, okay, which is the x component is partial f partial y, and the y component is partial sorry, the x component is partial f partial x, and the y component is partial f partial y. Okay, let's find the x component. So here we have our function fxy, which is 3x squared y. Differentiate f with respect to x, we get 6xy. That would be the x component. And the y component, we need to differentiate f with respect to y. That will give us 3x squared. Okay, now we can find the gradient or del of f at point P, which is at 1, 2. So that will give us, so what we do now is we just replace x with 1, y with 2. That will give us 6 times 1 times 2, which is a 12. So we have 12i. And then here we have 1 squared times 3, which is a 3. Okay, so now we can get the directional derivative of f in the direction of u, where u is the same direction as a, at point 1, 2. Oops, hang on. At point 1, 2 is equal to the gradient of f at point 1, 2. Dot that with the unit vector u. So this would be equal to 12i plus 3j dot with a unit vector, which is 3 over 5i plus 4 over 5j. So when you dot two vectors, what you get is a scalar. So x component multiplied with the x component, that would be 36 over 5. Y multiplied with the y component, which is 12 over 5. So that will give us 48 over 5. So that is the directional derivative of f in the direction of a. So the technique is we have to have a unit vector in the same direction as a. So divide a with its magnitude, get the gradient of f, and then dot the two vectors. Then you get the directional derivative. Okay, one more example. Let's look at example, the second one here. We are asked to find directional derivative of f at point 13, where f is this, and in the direction of pq, where p is point -13 and q is point 1 -2. Okay, I need more room. Okay, so second example. All right, so we have function f. We want the directional derivative of f in the direction of u. Well, it says direction of pq, so we have to find pq first. Okay, pq is the direction that we want. Okay, so point vector pq, what you do is you take the endpoint minus the starting point. So the x component would be 1 minus -1. The y component would be -2 minus 3. So vector pq would be 2, -5. And here you can see that the vector is not a unit vector, so we need to find a unit vector in the same direction as vector pq. So what we do is we divide vector pq with its magnitude. So we have 2i minus 5j divided by its magnitude, which is 2 squared plus 5 squared. So we have 4 plus 25, which is 29. So we have 2 over square root of 29i minus 5 over square root of 29j. So this is a unit vector which is in the same direction as vector pq. Okay, now we need del f, gradient of f, which is really partial f partial xi plus partial f partial yj. Okay, differentiate f here with respect to x by holding y as a constant. So the x component would be exy squared, and the y component, differentiate f with respect to y, we get 2exy. Okay, so now we can find the gradient of f at point 13. Okay, so that is a vector, so we just replace x with 1, y with 3. So we have e to the power of 1, 3 squared, which is a 9, and we have y is 3, 2 times 3 is 6, e to the power of 1 is e. Okay, so now the directional derivative of f in the direction of u, which is the same direction as pq, at point 13, is del f at point 13 dot with a unit vector u. Okay, so here we have 9ei plus 6ej dot with the unit vector u, which is the same direction as vector pq but in unit vector. We have square root of 29i minus 5 over square root of 29j, and here we have 18e over square root of 29, x component multiplied with the x component, minus 30e over square root of 29. Simplify this, we have negative 12e over square root of 29. So it's a scalar. So in this case, this one, in the second example, the directional derivative is negative. In the first example, our directional derivative is positive. Okay, in the next video, I will explain to you what does directional derivative means. Thank you.